Hello, my name is Jamsheed Agahi. I'm a VP of Quality Software at Semifore. Today, I'll be talking about two of the industry standards that are of interest to the verification engineer. One of those two standards is the Universal Verification Methodology, or UVM, and the other one is the Portable Stimulus Standard, or PSS. Let's start with UVM. The Universal Verification Methodology started out as an Accelera standard. Two versions that were of interest to the user community are UVM 1.1D and UVM 1.2. And in 2017, the standard became an IEEE standard, and it was called 1800.2/2017. With that transition, substantial changes were introduced to the API, namely deprecations and a lot of the implementation details that went away because they were not standard worthy. And there were some backward incompatibilities that were introduced. Later in 2020, another version of the standard came out that was IEEE 1800.2/2020. And with every version of the IEEE standard, Accelera released and continues to release the standard compliant library, the implementation. The current one that is compliant with IEEE 1800.2/2020 is called 1800.2/2020, and users can download it from the Accelera website. So with all these different versions of the UVM standard, how is the user community doing with adopting the IEEE standard? Well, the working group has found out that the industry is actually pretty slow in adopting the IEEE 1800.2/2020 standard. Much of the VIP has been written in UVM 1.1D or UVM 1.2. So due to the backward incompatibilities that were introduced when IEEE 1800.2/2017 was introduced, users felt that because of all the changes, it was just too difficult to move forward. It's just the sheer amount of changes that they had to make to their test benches prevented a lot of them from moving forward. So what is the working group doing to help users migrate to the IEEE standard? Right now, the Accelera UVM working group is working on developing a migration script that can do a couple of different things. One, it can actually identify areas in the user test bench that will need to be changed to be compliant to the standard, and also automatically make some of those changes, most of them, to the test bench. And for those that it cannot automatically make changes, it can recommend what changes need to be made so the user can actually make those changes. So that's the current state of affairs with the UVM. And now we can talk about the portable stimulus standard and where it's at. I think a lot of people are by now familiar with what portable stimulus standard is, but we'll just briefly talk about what it is. It's really a standard that enables the user to create a single representation of the stimulus and test scenarios that are usable across different platforms, and also different integration levels, like block level, subsystem level, and system level in a verification project. Now, what that means is that the user can capture the test intent and make higher level scenarios from lower level ones, build a formal representation of the test, and then hand that model of the test to the tool and let the tool generate the test for the different target platforms like simulation, emulation, FPGA prototyping, post-silicon, or whatever other target the user may have in mind. So essentially, the standard allows the generation of multiple implementations from one model. This is also, PSS is also an Accelera standard. In 2018, PSS 1.0 was approved. And earlier this year, 2021, PSS 2.0 was approved. PSS 2.0 actually includes a lot of improvements over 1.0, and we'll talk about the more important ones briefly here. One area of improvement was in storage allocation. In PSS 1.0, a lot of that responsibility was actually relegated to the user, which made it cumbersome. In 2.0, the heavy lifting is done by the tool, and the tool guarantees things like, allocations are unique. It also guarantees that the storage allocation is portable across tools. That's very, very important. And it also, the standard provides a core library address space API to help the user with managing the storage allocation. Another area of improvement was in high-level scenarios. The user can compose concurrent activities and capture scenario blocks and be able to constrain elements from above. That really helps with reuse significantly, where users don't necessarily have to, for example, be aware of the hierarchical path of, just as an example, hierarchical path of their activity structure. So that was a big improvement. Another area of improvement was enhanced modeling, which really means the user can have fine-grained scheduling control, which amounts to how to explicitly decide how activity termination is observed using things like different flavors of joint keyword. It also means that the user can influence attribute initialization in child components from the parent. So that's a concept that is referred to in PSS as top-down initialization, in addition to bottom-up, which was there before. And lastly, in the area of test realization, where stimulus is actually generated for a target platform, one of the important concepts that was introduced in test realization was the ability to define native target functions, where you can actually natively define a function in your test realization part of the model. Another concept that was introduced, which helps immensely with modeling, was the introduction of procedural constructs like loops and conditional statements, which don't exist in PSS DSL because these are procedural constructs and DSL is a declarative language. And finally, the ability to model programmable registers in PSS. That's something that didn't exist before. It helps a lot with being able to write your programmable sequences and allow the tool to generate that for different targets. Currently, the working group is working on the next generation, on the next version of the standard. and that will include errata and other requirements. Thank you.
Jamsheed, we have some questions from the audience. The first question, can you mix different versions of UVM in a single simulation or simulator?
Okay. This was something that the working group discovered was something that a lot of users were actually interested in. As part of what the working group is working on right now, there is going to be a compatibility tool set that will help specifically with this need. So users will be able to bring IP that was written in a different version of the UVM into their test bench, which might be written in a totally different version. For example, bringing in UVM 1.2 into an IEEE version, for example. So that's something that the working group will be working on and will be part of the future releases.
All right. The second question is in regards to portable stimulus, PSS. What's an example of a high-level scenario?
Okay. A high-level scenario, I think I briefly touched on that as I was going through the features of the PSS. If you've written an action that becomes part of a compound activity, which essentially means that you will introduce hierarchy in how a certain scenario is going to be modeled. Say you have an action around it, you have a loop, and you put it into another structure. So essentially, you introduce hierarchy for your action, for your scenario. If you want to be able to constrain an attribute down inside one of the sub-actions, you really don't want to know anything about the hierarchy, because what you will want to do is use your action in maybe other scenarios where the hierarchy is not the same as the one that you're working with. So what you want to be able to do is to essentially apply the constraint to certain types of actions in your subtree. And in PSS 2.0, the standard allows you to do that. So it makes this kind of scenario portable, so that if you want to apply a constraint to instances of a specific type within an action subtree, you will be able to do that. So you don't have to know anything about the hierarchy. So that's an example of a high-level scenario.
All right, and we've got, here's one final question. Are there companies providing PSS models for IPs like DDR?
I am actually not aware of any companies providing such IP in PSS, but I'm pretty sure there will be if there aren't currently. As you know, with the PSS standard, there are first of all, there are two ways to actually capture the intent. There are two languages. You know, there's the DSL and there's C++. So these two should be able to interact with each other. You should be able to mix models in both languages. And there will certainly be companies providing IP in PSS.
All right, well, thank you for your time this afternoon, Jamsheed. And that will end our recording.